Hi, Year 7. Today's title is probability. So, starting a new topic today that I don't think any of you will have come across before. So, get your title down, probability ordering, and then first thing to note. So, there's lots of writing here, so I'm just going to try and talk through it. Is that an event? So, an event is something that could happen in the future. That's our definition within probability. And we talk about the probability of events happening. Probability is all about the likelihood of events happening. So I'm going to introduce it using words. Then, because we're mathematicians, the next example we look at is going to be to do with numbers. So I've got a scale here. This is my probability scale here, and it ranges from impossible. So that is, it could never happen. The event could never happen to certain, which means the event will 100% happen. It will definitely happen. Notice I'm already starting to put some numbers on there. I'm saying 100%. This equally likely here is half chance of happening. So, exactly half chance of happening. Again, I'm putting numbers on it. Then likely and unlikely are somewhere in between half chance and certain and half chance and impossible. So that's my scale. Let's see how that relates to some events that I've got written down here that we're looking at happening. So first off, event A, and this is my notation that I use, P brackets, I will be in two places at once. So that means the probability of me being in two places at once. That's the notation we use. P standing for probability, then this brackets is what event am I looking at. So probability I'll be in two places at once, and this is where I usually get loads of hands up and people say, oh, but what if, and people's imaginations run away with themselves. But as far as I'm aware, I cannot be in two places at once. No one can. So I'm gonna put that as being impossible. Event A, I've labelled them just for ease, so I don't have to write it all out on my scale. Probability of event A being in two places at once, I'm saying, is impossible. Now, maybe you want to have a go at the rest. So have a go at putting B, C, D, E on here. But if you're not sure, then you can just keep watching the video and just pause whenever you feel necessary. So let's look at event B. A prime number having two factors. So that's the probability that I pick a prime number, and honestly, what's the probability that it has two factors? So let's say I pick 2, 3, 5. What is the probability that all of those numbers have two factors? Well, we know from, I think it was last week or the week before, that the definition of a prime number is that it has two factors. So that event is certain. If I pick any prime number, it's always going to have two factors. So that is certain. Right, next event, C. And again, maybe you want to pause, try and have a go at it. Probability of getting a tails after flipping a coin. So I flip the coin. What's the probability that it comes up tails? Well, there's two outcomes there. That it's a heads or a tails, so it's equally likely. I mean, it's equally likely to happen as to not happen. I could get a tails, I could get a heads. Those things are equally likely. And again, that's where people's imaginations start running away, and they go, "Oh, what if it lands on the side?" And that the probability of that actually happening, I've never seen it, so it's very small. So just to make our lives easy, just say it's a half chance of happening. Okay, event D. Got to find a colour. Let's go for orange. Event D. Probability it will rain this week. So in Britain in spring, there's probably quite a high chance of it happening. Probably quite close to certain. I'd say even more likely than just likely. So I'm gonna put event D around there. Some weeks it might change. Like as you move towards summer, it might sort of go a bit lower and be less likely and move along this scale. But I'm gonna say for this week, that it's pretty likely it will rain at some point. It might even be closer to certain than what I've put it, but it's not an exact thing. Right, event E I'm on now. Let's do light blue. Whoops. So probability you'll pick a diamond from a pack of cards. So a pack of cards has 52 cards in it. It's split up into diamonds, hearts, clubs, and spades. And there's more of those other cards that I've mentioned, the hearts, clubs, and spades, than there are diamonds. So it's actually not that likely to pick out a diamond from that whole deck of cards. So I'm gonna put it as being unlikely. Right, now it is your turn to come up with your own event, call it event F, and write P brackets for the probability of it happening, and then try and place it on there. Right, I'm going to come up with my own, so pause the video if you haven't quite done yours yet. Probability Brighton will win the Premier League. So that's just they will win it at some point. The probability they will win it at some point, not this season because they can't win it this season, it's impossible. But at some point, what's the probability they will win the league? Well, I would like to think, or I want this to happen, so I might be tempted to say, oh yeah, it's really likely. But actually, that's just what I want it to be. It's not what it actually is. And then some of you might like to say, well, it's absolutely impossible because Brighton are rubbish, blah, blah, blah. But in truth, it's pretty unlikely. It's not impossible all the time they're in the Premier League. It's not impossible. Or all the time they're playing football. It's not impossible because they could win the Premier League at some point. But it is pretty unlikely, I have to say. So I'm going to put it down here. Think about when Leicester won the Premier League. People would probably say, yeah, that's unlikely as well. But they did it, so it can happen. But Brighton is probably pretty unlikely. If I came up with another one, the probability of Palace winning the Premier League, then that's probably just a bit lower than that. So let's call that event G. That Palace win the league. And again, maybe that's my bias coming in there. Bias means that it's an unfair opinion, and I am biased because I am a Brighton fan. Right, so that's probability in terms of words. As I said, we're mathematicians, so we want to put numbers on it. So I've got my scale here, and some other ways we can write probabilities are as decimals. So going from 0 to 1, and you have all your decimals in between, 0.5 being half likely. Can have fractions, going from 0 to 1 again with all your fractions in between, so 1/2 is the fraction there. And you can have percentages as well, so 0, 50% up to 100%. Notice that's different, it's not 1 but 100%. So they're all your forms that you can have probabilities in, as well as your words that we've just learnt. But going forward, we're more likely to start using numbers because they're more accurate than just saying words. So, I've got an example here of some counters. Let's say they're in a bag, and let's imagine I close my eyes, dip into the bag, and pick out a counter. So I've got all these counters in a bag. Close my eyes and randomly pick one. So here, for my worked example, I want the probability of picking a red counter. So how I'm going to do that is see how many reds there are. So there's 1, 2, 3, 4, 5. And I'm going to put it as a fraction. I quite like having probabilities as fractions. And how many are there in total. So out of how many? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 counters in total. So the chance of picking a red is 5 out of 10 because there's 5 reds out of 10 in total, and I can simplify that to 1.5. You don't have to simplify, but you can do. So they're my final answer. That's my final answer. So to get down a definition of the probability of event is the number of desired outcomes. So desired is like what is the probability you're looking at. In this case, my desired outcome is red. So the desired outcome over total possible outcomes. So total possible outcomes, in this case there was a total of 10 counters in the bag. Right, make sure you've got that down in your book, nice and neat and big, because it's a really important formula. Right, for your turn then, I want the probability of picking a yellow. Pause the video, have a go at it, I'll go for it now. Right, a yellow, so there's 2 yellows, and I know from before that there's 10 in total. Maybe you simplified that 1/5. You could leave your answer as either. So that's the probability of picking a yellow. Next thing I'd like to do, next and final thing I'd like to do is, can you tell me the answers to these questions here? Pause the video, have a go at them, I'll go through the answers now. So probability of picking a green, same as a yellow because there's the same amount of them, is 2/10. Could simplify that to 1/5, but either way, give yourself a tick if you got it, or you could have 1/5 is also correct. Green and yellow, so probability of picking, well that shouldn't say and really, that should say green or yellow, because it would be impossible to pick a green and the yellow because I'm only picking one counter. It can't be, there's no green and yellow counters in there. There's either green or yellow. So the probability of that is there's 2 greens and 2 yellows, so that's 4 out of 10, or 2/5. So sorry if I threw you there with the and, it should have been an or, just like this one. So maybe have another go at the third one if you were thrown by my my mistake there. So blue or red, well there's 1 blue and there's 5 red, so that must be 6 out of possible 10, which we can simplify to 3/5. Give it a tick in red pen if you got that. Probability of picking an orange, well there are no oranges there, so I cannot do that, so the probability is 0. Right, well done for your work today. Can you take a picture of your work from your book and upload it to Show My Homework once you've finished watching the video and finished all these tasks? Have a great rest of your day.